All right, in our first lesson in organic chemistry, we're going to take a look at hydrocarbons. And hydrocarbons are compounds that contain hydrogen atoms and carbon atoms. So let's take a look at a few examples. So on the bottom of the screen here, I've got methane, ethene, and ethine. And these three are three different types of hydrocarbons, but as our lessons progress, you'll understand that a little bit better. For now, all I want to focus on is the fact that it contains carbon and hydrogen and what variations you can see in the bonds between the carbons, right? So in methane, which is an alkane, you'll see that carbons are single bonded to other carbons and single bonded to hydrogens. So hydrogens can't form double or triple bonds, but whenever possible, the carbons would only be single bonded in our first type of hydrocarbon. In our second type, which is ethene down in the middle, you'll see that our carbon forms a double bond with another carbon. So as long as there's at least one double bond, you're looking at an alkene, which is a type of hydrocarbon. And on the right side, you've got ethine, which is an example of an alkyne, which contains at least one triple bond. So the three types of hydrocarbons, at least the ones that we're going to be looking at, are alkanes, alkenes, and alkynes. More on them as we learn as our lessons progress. So this would be an alkane, this would be an alkene, and this would be an alkyne. Another very important part or thing that I want to bring to your attention is that regardless of if there's a single bond, a double bond, or a triple bond, the number of bonds that the carbon has always remains 4, right? So if you take a look here, I've got 1, 2, 3, 4. 4 bonds to this particular carbon. Even when the carbon is forming a double bond, you see that if you count the individual number of bonds, it is 4. So I've got 1, 2, 3, 4. And same with this one. And even when there's a triple bond, 1, 2, 3, 4. This is always going to be true. Carbon is going to have a total of 4 bonds. And this is because of the fact that carbon has 4 valence electrons. When we're drawing these hydrocarbons, or just organic compounds in general, knowing this would be very, very useful for us because it makes our process of drawing much, much easier. So let's talk about alkanes. So those are our first type of hydrocarbons. And as I mentioned earlier, these are the ones that only contain single bonds. So only carbon, carbon, single bonds. Right? And there is a formula associated with alkanes. And what do I mean by formula? It just is a easy way for us to figure out the chemical formula for any alkane, as long as you know the number of carbons. So for example, in this case, for alkanes, the formula is CnH2n plus 2. So if I know that there's 5 carbons in an alkane, I take that number of carbons, if I multiply it by 2 and add 2, I will end up with the number of hydrogens for that particular compound. And when we draw structures, it is going to be, you're going to understand where those hydrogens are specifically placed. But in terms of just identifying formula, you should be able to do that very quickly as long as you know the number of carbons. Let's take a look at an example. So if I'm telling you that it's an alkane and I tell you that there are 3 carbons, if it's an alkane, I know the number of hydrogens because the value of carbons times 2, so 3 times 2 is 6, plus 2 is the number of hydrogens. So my 3 carbon alkane is always going to have the formula C3H8. And now when we're naming them, so you might have noticed that in the very first slide, when we looked at an example, we had methane, right? There are very interesting names that comes for these alkanes, and all have to do with the number of carbons, right? So if I tell you that we're looking at pentane, you should know the number of carbons just by looking at the name. So again, all of these things are related. The whole point of naming in organic chemistry is that if you name something, or if you tell someone that you're looking at a particular compound, if that person has some knowledge in organic chemistry, they can decipher exactly what particular compound you're talking about, right? And part of that has to do with the prefixes. So for alkanes, our prefixes go like this. So if you have 1 carbon, the prefix is meth. If it's 2, it's eth, 3, prop, and so on and so forth, right? And the ending is actually going to be different based off of the hydrocarbon. So these prefixes stay pretty consistent for pretty much as we go in organic chemistry. This kind of stays the same. What changes is the ending, or the suffix. So if you're looking at an alkane, the ending is always ane. So if you see the ending ane, you know you're looking at an alkane. So let's just go back to that first slide so that you can see here. So methane is what told me that that was an alkane. And if you look ahead at the alkenes and alkynes, you might be able to understand what those endings might be. But again, when we look at those lessons, we'll understand those a bit better. So if we were to say draw a particular compound, you take a look at the prefix to tell you how many carbons there are, and then you take a look at the ending to figure out how many, or if there are any double or triple bonds. So let's do an example. Let's do butane. So if we were to try and draw butane, there are 3 ways that we can do that. So I'm going to write butane up at the top here so that we know we are looking at this particular compound. So I'm going to try and break apart the name to identify its components. So first of all, I know the ending is ane. And the ending ane tells me that that's an alkane. That means there's only single bonds in this particular compound. Now the other part, the first part, the prefix tells me it's bute. Now bute is the prefix for a 4-carbon molecule. So I always want to start off by drawing my carbons first and then filling in the hydrogens wherever necessary. So because I know that there's a 4-carbon molecule, I'm going to draw my 4 carbons. And I'm going to draw them to be in a chain. And in most hydrocarbons, the carbons are all linked together. So you can start off by connecting each carbon to each other with a single bond in a chain setup. Now, as I sort of mentioned at the beginning of the slide, there are 3 different ways that I can draw butane. The first one is much more detailed. It takes a bit more time. The second one is a little bit less. And the third one is very short. I will require you to know all 3 of these, because if you look in your textbook, they're used interchangeably, right? One is not more correct than another, but some of them might be a lot easier to draw than others, especially if we get into our more complicated and our longer structures. So in our first way, we are showing all of our bonds, right? So in butane, I know that there are 4 carbons. So I've drawn my 4 carbons. And because it's a hydrocarbon, everything else is going to be a hydrogen. So I just have to take a look at each carbon and see how many bonds it has and how many bonds it needs. So this particular carbon, it has already formed 1 bond with another carbon. So like I said earlier, the carbon needs to have 4 bonds in total. So because it already has the 1, it's going to be bonded to 3 hydrogens, right? So I'm kind of working backwards here, where I'm starting with the number of carbons and then adding in the hydrogens as I'm going. So I want the total number of bonds for each carbon to be 4. For the second one, I can see that because it's in the middle, it's forming 1 bond with this carbon and another bond with that carbon. So in total, it has 2 bonds already. So I'm going to go in and add 2 more hydrogens. And doing that will make this carbon to have 4 bonds. And I'm going to continue that process for the last 2 carbons as well. So you want to be familiar and you want to be pretty quick with identifying how many hydrogens go with each carbon depending on the compound that you're looking at, right? Really, there's two possibilities. Either you've got a carbon on the end where it needs 3, or you've got a carbon in the middle where it needs 2. Especially with these alkanes, it's a little bit more simple. Right, so this is my first way of drawing my butane. So let's just make sure that we have the correct formula and structure, right? So let's check this out. So I've got 4 carbons here. According to our formula, we should have 4 times 2 is 8 plus 2 is 10. So I should have 10 hydrogens here. So let's count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So that means that I've got this correct structure. My second way of representing this molecule is pretty much the same, except I'm not drawing all of these individual bonds out. So I'm going to start again the exact same way I did by drawing my 4 carbons all bonded to each other. And in this case, instead of drawing out each single bond, I'm going to sort of condense them. So instead of drawing 3 bonds and then writing H 3 times, what I'm going to do is see how many hydrogens does this carbon need. I know that it's 3, so I'm just going to write H3 here. So I'm going to have CH3 like this. So the structure is still drawn in that you see those bonds between the carbons, but you don't necessarily see the bonds between each carbon and the hydrogen, right? You're trying to make your life a little bit easier here. So for the second one, I see that it has 2 bonds. I'm going to put in CH2, CH2, CH3. This is what we call the condensed structure. So it's a little bit more condensed. It's a little bit easier for us to draw. And you can see as you're copying this down, it's a lot quicker as well. And that's what it kind of comes down to, right? If you're drawing long structures, which is the easiest, which is the quickest? So this is sort of the condensed structure. And then the third of which is what we call a line diagram. And in the line diagram, you are actually not writing any of your atoms out. You're not writing any letters at all. We just assume, especially in chemistry, and especially in organic chemistry, where we have a lot of hydrocarbons, we are actually just going to draw lines. So when I'm drawing butane, each carbon that I have is going to be one end of the line. So I have 1 carbon here, another carbon here. So that's going to be 2 carbons. And then because I have 4 carbons in total, I'm going to draw another dot. So that's another carbon and another one. So that's 4. So if you want to just sort of follow along with me, that's 1, 2, 3, 4. So each end of a line kind of becomes a carbon. So obviously, on the very right side, I've got the line diagram. That's the quickest, right? If I know that there's 4, I don't need to account for all of the hydrogens. The person looking at it, if they know organic chemistry, will just know that there is the appropriate number of hydrogens, right? So I don't have to go through all of that work of trying to figure out how many hydrogens are in each step. And more so, it's not the figuring out that takes a while. It's the drawing all of it that takes a while, right? So that's what we can sort of condense with our line diagram. So these are the 3 ways that you will see organic compounds written. If you are writing or drawing a diagram for me, it doesn't matter which of these 3 you use as long as you are correct, right? So just make sure that you are practicing each of these and you're familiar with all 3 of these. So if I'm giving you a compound in a line diagram, you know exactly how to name it and draw it, etc. All right, let's take a look at a few examples of our alkanes. So sometimes they would just be straight chains of hydrocarbons, right? So just a bunch of carbons linked together with a number of hydrogens associated with it. However, you can have a slightly more complicated set of hydrocarbons, right? So when you're naming them, things get a bit more complicated. So if you take a look at this structure here, this is our first example. It's a little bit more complicated. Our first step is always to identify the longest continuous carbon chain. So if we take a look at this particular structure, there's a few ways that I can do it. There is a correct method to this, and as we go through our next few examples, it'll become obvious to you, but let's start from left to right, right? So I'm gonna maybe choose a different color here. So I'm gonna start here. Let's say this is 1, 2, 3, 4, 5. So I want to number the longest continuous carbon chain. So I've got 5 carbons there. So you'll notice there's this whole carbon here off to the side that is not part of our chain. That's totally fine. We will name that later. So there's a few ways that I can name it, right? So I can name it from left to right. So 1, 2, 3, 4, 5. Or I can name it from right to left. So if I wanted, I could do 1, 2, 3, 4, 5. Oops, and I think this carbon is missing a hydrogen, so I'm just gonna write that in there. So I've got a few different ways, so left to right or right to left. There is one way that's most correct, and we'll get to that towards the when we actually name this. So let's identify what our alkane name would be here. Let's choose, I'm gonna go with red again. So because there are 5 carbons, I know that we're looking at pent, and I don't see any double or triple bonds, so I know that this is pentane. All right, now I have to account for this particular carbon here. So whenever I have a carbon that's not part of our longest continuous carbon chain, I'm going to call this a side group. And my side groups are very important because that plays a role in where or what our name for our particular compound is, right? So in this case, my side group has 1 carbon. So my side group has 1 carbon. Again, those prefixes are very, very important. So my prefix is meth. But if I'm naming a side group, instead of having the ending ANE, I'm going to have the ending YL. So this is going to be methyl. So I know that the methyl is associated, is going to be a part of this compound. So I've got methyl pentane. The numbering becomes important because I have to specify where on this particular 5 carbon alkane this methyl group is attached to. So if I take a look from left to right, if I number 1 to 5, it would be on carbon number 2. If I number the longest continuous carbon chain from right to left, it would be on carbon number 4. So you can see why that can be confusing if we don't have a set rule for how we should name it. So the answer to that is we have to number our longest continuous carbon chain so that our side groups have the lowest number possible. So when I numbered it from right to left, that's actually wrong. So I'm going to cross those out. So when I cross that out, the only numbers that I have, the only correct numbering is from left to right. So my correct answer is 2-methylpentane. And that is the name for this structure, and that is the only correct name for this structure. Now, a few things to note here. The YL is always going to be the suffix for a side group, right? Let me just put that arrow there. It is always, all of your side groups have to end in YL. When we get into more complicated functional groups, we'll talk about those later. Obviously, those cases might be different, but if you've got just like another piece of or another hydrocarbon as your side group, it has to end in YL. And I want to number it so that it has the lowest number. So in whatever possible numbering that I give, I want it to be attached to the lowest possible number. So in this case, that was 2. Whenever I have a number in my organic naming, I want to separate the number and the word with a dash. This is a hyphen, right? And I always want to include that anytime there is a number before or after a name. Okay, we'll look at another example. So this one's a bit more complicated. similar to the last question, I think there's a hydrogen missing here. So make sure that you maybe pause the video and copy this all down. And then we are going to name this together. So again, the more complicated part of naming is to figure out which is our longest continuous carbon chain. So I'm going to show you a few possibilities and we can think about which one of these would be correct, right? So let's take a look. I'm going to choose my blue again. I'm going to start from left to right. I'm going to go with that first. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I see 8 there. I'm going to go from right to left as well. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've got a few different possibilities. So either from left to right or from right to left. Based off of our side groups, we can figure out what is right. And what's right is going to have the lowest possible sequence of numbers, right? So this side group here could either be attached to 3 or 6. And this side group here could be attached to 4 or 5. And this side group here could be attached to 5 or 4, right? So clearly, in my numbering system from left to right, my side groups would be on 3, 4, or 5. Whereas if I go from right to left, it would be 4, 5, and 6, right? So I want the naming convention that could have the lowest number of lowest numbers possible. So I'm going to go right ahead and try and name my parent chain, my longest continuous carbon chain. And that is, it has 8 carbons, so that would be oct. And because I don't see any double or triple bonds, I'm going to end it with ane, so octane. And then now it's time to include our side groups in. So on carbon 3 and 4, I see 1 carbon each. So this particular group is meth, right? And this is a side group, not an alkane. So I'm going to have methyl here. This is another methyl because there's only 1 carbon there, right? And the carbon that's in your parent chain, you don't have to count that with our side group, right? Because we've already accounted for those when we did our parent chain. So you don't need to be redundant there. So we only need to account for carbons that are not part of the parent chain. Now, if we're looking at this side group, I've got 1, 2, 3. So I've got prop as my prefix. And because again, this is a side group, it will be YL. Okay, so there's a few different things I have to look at before I put these all together. So I've got 2 different types of side groups. If ever I've got the same ones, like I do here, I've got 2 methyls, what I'm gonna have to do is combine them together or write them together as dimethyl, right? And that di just comes from the fact that there are 2 of the methyl groups there. So when I write it into my name, I'm not writing methyl, I'm just writing it as dimethyl. And then I have propyl as well. So I've got dimethyl. I'm just going to sort of write this all together to see how we're going to put it together. Dimethyl and propyl. And my numbers are, I've got 3, 4. So 3, 4 dimethyl. And my propyl has the number 5. So these are all of my components. So this is my side group, this is a side group, and this is my parent chain. My full name for this organic compound is going to have the side groups and the parent chain all put together. I always want to arrange my side groups in alphabetical order, right? So L, M, N, O, P. So M comes before P. And these di, tri, whatever your prefixes are, those don't count in the alphabet ruling, right? So you just look at the M versus the propyl. the M versus the P. So the methyl comes first. So I'm going to write 3,4-dimethyl. Oh, I'm running out of space here. Let me just write that again. So 3,4-dimethyl. Right, so here's the thing that I said again. So I've got 3 and 4. Those are numbers. If I'm ever writing two different numbers together, I've got to have the comma separating them. If I have to separate, if I have to write numbers right next to letters, I'm going to have the dash separating them, right? So right after my diethyl, I'm going to have the number 5. So I'm going to put a dash and then 5. Propyl. Right, so there's a dash before the 5 and after the 5 because it is coming immediately after a letter and going before a letter, right? So I need to separate that with the dashes. So 3,4-dimethyl 5-propyl octane. Okay, so that is the name for this particular organic molecule. So that's how you'd name these structures. We'll do some practice for drawing as well tomorrow in class. But for now, I just want you to get used to drawing these out and naming them. So there's a few practice questions underneath the video on D2L that you can look at. I also think it would be really good practice if you just start from methane and go to decane and draw the first 10 hydrocarbons just as alkanes. I think that would be really, really good practice, and you can cross-check that with the formula to make sure that you've got the appropriate number of carbons and hydrogens. But that's pretty much it for this section of the hydrocarbons lesson. Bye.